hopefully you understood the solution to the Mad Libs that used regular expressions. I'd like to talk about an approach that would not use regular expressions. Um, so the first way that I would start off, if I was going to try to write this, would be to maybe just write a function to make sure that I can find the brackets. So if I'm not going to use re sub, then I need to know the position, the starting position and the ending position for a pair of brackets. So I might imagine writing a function called find brackets like this. It's going to take some text and it's going to have to return the start and stop positions. And so I would first imagine, well, if I run this function with, say, the empty string, it's going to return none. Now, there's a lot of different ways that you could indicate, I guess this is a failure, or it's simply just the result. It's a failure certainly to find the thing that you're looking for, but it's not necessarily like some error that would cause the whole program to fail. So there's lots of ways you could approach this. Some people like to use exceptions, and they would raise some sort of an exception to say no brackets found. I'm not a huge fan of exceptions. I try not to program them myself, and I tend to not handle exceptions in my code. I actually just I use what's called the happy path idea, where I basically code the program to follow the happy path that doesn't have exceptions. And if there is an exception, I really just want the program to just completely fail, and I'll have to deal with it later. It'll just be a runtime exception. And that's basically the way I approach when I code in Python. In other languages, I have a different approach. So here, I'm not going to raise an exception here because I don't find angle brackets in the empty string. I'm just going to return none. None's going to be the value that my calling code will have to understand means that I didn't find anything. In other exercises, for instance, in that stemmer function I wrote, that was having to do with the rhymer program, I decided that function would always return a tuple that was the first part of the word and the second part of the word, and it was up to the calling code to figure out if that meant that the word could or couldn't be rhymed. And so here it's kind of the same thing. I've decided that I'm going to return none to say that there were no angle brackets, but when it does work, it's going to return a tuple. And that tuple is going to have the start and end position. So it's really going to be up to my calling code to figure this out. In another language, I might use something like a result or some sort of an option to wrap this. I'm not actually comfortable returning two different things. And so when we get into talking about typing, we can actually describe this function as returning an optional tuple, because when there is something present, it's going to be a tuple. When there's not something, the only other option is that there will be none. So that's a very long-winded way of just talking about how to go about the design decisions that I made here for this function. So when this brackets is going to be looking for angle brackets, but there has to be something in the middle. And so I also have a test for that where there's angle brackets but nothing, and so it's still going to return none. But when there is an angle bracket with some text in the middle, it's going to return the start and stop positions of those. And so I have a few test cases, good and bad input, and I make sure it works. And here's how I would write that function. I would look for the index of this, but you have to remember that string index will throws an exception if the thing that you're looking for, the character or the string, does not exist in the string. So I have to say if the angle bracket is in text, else I'm going to use the value of -1. I could not use the value of 0 because 0 is a valid index. It would be the first character in a string. So I'm going to use -1 to say that it's not there. Then I need to say if the start is greater than 0 and there is actually a right angle bracket starting from that start value going two positions over, looking in the next part of the string further ahead. If both of these conditions are true, then tell me what the index of the right angle is, else return -1. And then I'm going to return start and stop if it's true that both of those values are greater than or equal to 0, else none. So that's how I decided I would write this find brackets. So that's the first piece that I decided that I needed if I was going to write this without regular expressions. It works pretty well, but it's not going to handle this case very well. And this was something I talked specifically about in the intro about writing a character class that does not contain a character class that describes all the characters, not the right and left angle brackets. So this code, while it's pretty clever and does basically work, it's not going to work on this. And so I would have to write a good bit more code to make sure that I'm not finding this kind of work. Because if I look and test this, then it's finding this unbalanced pair of braces. And that's important to know because in HTML, you could see this a lot. HTML is actually really notorious about having these kinds of errors in it because a lot of it, especially honestly, when I started writing, some of the earliest stuff that I wrote was HTML, and I'm sure that I made manual mistakes, and people still today hand code HTML, probably not as much as before, and so these mistakes still creep in, and also software that generates HTML can be buggy and can create unbalanced angle brackets like this, and so HTML parsers actually have to be pretty lenient in the parsing of HTML. So my find brackets is not going to work completely on that. The way that I would incorporate this, it looks a good bit different now. I set up this while true to create an infinite loop. And then I need to look in the text for some brackets. And if there are no brackets, then I'm going to break out of the loop, which means that either I never saw anything or I have replaced them all now. And so if I'm breaking out because there just aren't any to be found, I need to know that. So I have to establish this variable up here that I had some placeholders. And I initialize that to false because I assume the worst. I assume that I didn't see. So as soon as I do see some brackets, I'm going to have to make sure that had placeholders, I need to make sure that that gets set to a true value. Because if I exit out of this loop and I had placeholders, then I'm going to print the new text. Otherwise, I'm going to print this long-handed way of jumping out of the program and saying that there were no placeholders and printing that to standard error and all that. So if there are no brackets, if that's none, then I'm going to break. Otherwise, I have two things in brackets and I can unpack them into start and stop. The placeholder then can be found going from start to stop +1. I have to include +1 because the stop is going to be non-inclusive. The part of speech is going to be inside that placeholder. So if the placeholder is angle bracket, adjective angle bracket, then I'm getting just the stuff inside the angle brackets. And now I'm going to have to choose my article so that I can then ask the answer. This is the same thing that we just saw before. I'm either going to ask for give me an adjective or a noun, or I'm going to get it off inputs. And now I need to manually take the text up until the start position, substitute in the answer, and then take the text after the stop position for that placeholder. And I set that to text to be that new value. Then when I come back through the next time through, I find the next set of brackets. So whereas in the first one, in the regular expression, I did this find all, and I just found all of the patterns in one go. But I can't do that in this version because adjective and with the angle brackets is something like 10, 12 characters. But the thing that I'm going to be putting in might be blue, which is 4 characters. So now the text has changed, and the positions of those placeholders that were after adjective are going to be in a different position after I've replaced the placeholder with the new value. So I have to find the brackets each time through until I've run out of finding the brackets. So I think it's fun and interesting to try to solve problems in a very, very manual way like this. I think it just pushes you to understand the language more, but it's not a good solution. The regular expression solution, I think, is far more natural and makes a lot more sense. Um, and so I would definitely not recommend writing this, but it's very interesting to think about. With using regular expressions, we're basically able to declare what it is we're looking for and let the regular expression engine do all of this kind of really brute force work that without a regular expression engine we would have to do. So I think it gives you, it's basically like suffering builds character. So if you write this and you suffer through it, then you actually come to realize exactly what regular expressions bring to the table. So that was the Mad Libs. I hope that you enjoyed that. Regular expressions, they allow us to describe these patterns of text, and then we don't have to do all this dirty work to actually find them. We talked about regular expression patterns that are declared with a star or the plus sign are greedy. And so in order to make them not greedy, we have to add a question mark after them. We use the find all to find every instance of a given pattern, and then we used resub to substitute a given pattern with some new text. And we talked about how we can use sysexit to bail out of a program, print a message to standard error, exit with a non-zero value, so that we indicate that there is, to the greater operating system, that there was an error. So other things that you can do, I suggest some other exercises and going further. Other things that you could look for, parentheses or square brackets. So I hope this was an interesting program, and we will continue on to the next chapter.